So I want to say something about efficiency. We've been drawing this map, and here I've modified my function to have my draw map function to be 32 by 32, and just draw all the boundary edges, which is what we're seeing here. So that's 128 cubes, right? 32 on 4 different sides, 128 cubes that we're trying to draw. And I was starting to get lagging problems when I did this. So I've modified my render function to have a new render function, which is render fast. So let's take a look at what was going on and why I had to do this. So we go inside of our cube and we look at our render function. So inside this function, what we were doing was we were calling draw triangle, right? And we may be using the UV version, or we're maybe using the non-UV version, but we're making a lot of calls to drawing these triangles. So what's happening inside of each of these triangle calls? Okay, so we go over here and we look inside of our draw triangle 3D. What we see is we're creating a GL buffer, we're binding that buffer, we're sending our data into the buffer, making some other calls, and then finally calling draw arrays. And for each cube, we're repeating this 12 times, right? We have 12 different triangles in each cube, and for each cube, we're repeating, doing all of these calls into GL. And somewhere in these calls, things are slow. You can imagine creating buffers might be slow, or who knows which piece it is. But we don't have to send just one triangle at a time. WebGL is set up to accept multiple triangles. In fact, that's the way it's expected to be used. So what we're going to do is we're going to go back to our cube, and we're going to modify. So I'm going to take this render function, and I've just copied it down into a render fast function. And what I've done is I've defined a new list of all the vertices that I want to draw. And I'm going to start it out empty. And now, instead of calling draw triangle, I've taken these exact arrays. This is exactly the array that I had defined up here for my first triangle. So I had some array for my first triangle. I've left out the UV components because I'm just trying to demonstrate how this would work. But we take exactly these things, right? So this is a bunch of vertices for the first triangle, a bunch of vertices for the second triangle, a bunch of vertices for the third triangle. We come down here inside of our render fast, and I'm just going to add these vertices onto a single list. So what does this concat do? It just is a concatenation of whatever is the existing with it, and it returns a new vector, so you have to reassign it back into all verts. So anyway, when I get to the bottom of all of these, I have now got not just 3 vertices and 9 points in my list that I'm going to pass into draw triangle. I'm not going to pass all this stuff, so there's going to be hundreds of numbers that are in here, right? Because it's going to be 9 times the 12 triangles I have to draw. They're just going to get passed into draw triangle 3D. Now this is not really a triangle anymore, it's 12 triangles, but it happens that I had my function set up so that it will take any number of vertices, right? So I'm going to calculate the number of vertices as how many got passed in divided by 3. And down here, I'm going to tell it to draw the right number. And we just pass all those vertices in with our buffer data call. So draw triangles is going to work in the right way, even though it's not a triangle anymore. It's going to draw the whole list of triangles that we've stuffed into our buffer. So I can call this with all of the vertices. So this should give me a speed up of 12 on drawing my cubes. And as I usually do, I didn't go change my render function. I made myself a new render fast function so that I could easily tell what's going on. So let's go take a look at what's going on when we actually run this thing. So if I run my original render function, we can see it looks like I'm taking, I don't know, usually around 9 or 10 milliseconds per frame, and sometimes much longer, probably when it's doing JavaScript's doing garbage collection or some other thing is happening. So it's lagging. When I try to turn, I can barely turn. When I try to move, there's lagging, and it's difficult to use. If we switch to our render fast function, now I have much better performance. And we can see that each frame is taking, I don't know, 1, 2, 3 milliseconds. There's occasional still a lag out while something's getting collected, but I've been able to get a huge speed up in terms of my overall performance by changing to sending multiple triangles at one time. So the code that we've built up so far, where we send one triangle at a time to WebGL, is a really inefficient way to do things. What we would really like to do is to build up longer buffers and send the entire buffer in. Now for my whole map object, right, so here I've got a map, I'm still taking each cube, making that cube, and then sending all of the vertices for that cube together. But you can imagine getting all the vertices for the entire map together into one list and then calling that in order to run. And that's going to be substantially faster if you go down that pathway of trying to pack all of the things that you want to draw into one list and sending it to WebGL at the same time. Now there's a couple of details. We were previously in our cubes rendering with different colors on the edges. Well, I did that by passing a uniform because I had each triangle separate. But now if I want to pass colors for a whole stack of triangles together, I'm going to have to pass those in an attribute variable. I'm not going to be able to use a uniform anymore. So the same way we had to make a secondary attribute variable in order to get our UV coordinates passed in, we're going to need another attribute variable to get our colors passed in should we want to do that. So we're going to have all of that information stacked up in an array, which is going to get passed in. But the general idea is by sticking all of these into long lists, we can get an efficiency improvement in terms of our rendering, where we won't lag nearly as much and we can deal with more. So just the simple thing of fixing cubes got me up to rendering 128, where I'm not having too much lag. But you may have to take a step further and pack these things into a single list. This may also mean modifying your cube function. So right now I'm using translate to move around my cubes, but remember our model matrix is also getting passed in as a uniform, and we have one per cube. So if we want to go and take the next step where we're going to put all of our cubes into a single thing, we may have to modify our cube function to know something about the translation and to calculate it on the fly rather than using a matrix to do it, so that all of the vertices for our map are stacked raw into a list.